In this video, we are going to go over solving systems of equations algebraically. We are going to use substitution. On the first page, we are going to add two examples. We're going to add this one on the left and this one on the right. They are lines. When I solve algebraically, I'm going to take this equation and set it equal to the other one because they both are y's. 7/3 x minus 3 is equal to 1/3 x plus 3. In order to get rid of the fractions, I'm going to multiply everything by 3. Those 3's would cancel and leave 7x. Minus 3 times 3 is 9 equals 1x plus 3 times 3 is 9. Now that I have no fractions, I can combine like terms, so I'm going to minus x so that it is over with the 7, then add the 9, 6x is equal to 18, divide by 6, and x equals 3. After you solve for x, you plug it in. You can pick either equation. I'm going to plug it into the bottom one. When I type that into my calculator, those would cancel. 1 plus 3 is 4. If I write it as a point, I would write x, comma, y. Let's try the second example on the right. I take my two equations. I'm going to substitute this one in for y, so I get 7/3 x minus 4 equals 3 over 2x plus 1. Get rid of the fractions. I'm going to multiply by 3. Those would cancel, and I would get 7x minus 3 times 4 is 12. Those don't cancel. 3 times 3 is 9 over 2x. Plus 1 times 3 is 3. I still have a fraction, so I'm going to go through and multiply everything by 2. That would be a 14x minus 24 equals, those 2's cancel and leave 9x. Plus 3 times 2 is 6. Minus the 9x. That leaves us with 5x. Minus 24 equals 6. Add 24. 5x equals 30. Divide by 5, x is equal to 6. Once I find x, I plug it in. I'm going to plug it into the top one. And when I do that, I think you get 10. 7 divided by 3 times 6 minus 4 is 10. Y is 10. X, comma, y as my point. On example 1, I do the same thing. I say that x squared minus 11x plus 28 is equal to that negative 3x plus 12. I want everything on the same side because of this x squared. That's what signals to me that everything needs to be on the same side because it's a quadratic. I add 3x. I minus 12. That gives us x squared minus 11, 10, 9, 8, x plus equals 0. From here you can factor, or you could use the quadratic formula. If I factor it, let's try and factor. 16 would be 2 times 8 or 4 times 4. They would both be negatives to get negative 8 when we add them up. That means x equals 4, and this x equals 4. I plug it in to find what y equals. I'm going to plug it into this y right here. I would get negative 3 times 4 plus 12. When I enter this in, I get that y is 0. If I plug 4 in again, I would just get the same answer. As a point, it's x comma y. So that would be the only solution for those equations. If you want to graph it, you can to check your work, but you don't have to. Example 2, I have my two equations. I'm going to set them equal. X squared plus 4x minus 2 is equal to 3x minus 3x from both sides. X squared plus 1x minus 2 equals 3x. I'm going to move the 3x over to be under the 4. So we subtract it from both sides. We get x squared plus 1x minus 2 equals 0. When I factor it, we put our parentheses. Then we have the x's in front. Multiples of 2 would be 2 times 1. And my sign would be a positive 2 and a negative to add up to positive 1. After factoring, I now can solve it and say that x equals negative 2, x equals positive 1. Then I'm going to plug those x's in. So I can pick either equation. I'm going to plug it into the top because it's a little easier. If I plug in a negative 2 for the x, I get that y is a negative 6. There's 1 point. Then when I plug in a 1, I get that y is equal to 3. If you want to write them as a point, you can. If you want to leave it as x and y, that's also fine. And those would be your two solutions where your quadratic U-shape is intersected by the line crossing through it and hitting it 2 times at these points. Just a reminder, the reason I know why to move everything over to the same side is because there's an x squared. Whenever there's an x squared, we want to move everything to the same side so that it's in the form ax squared plus bx plus c equals 0. That's why I was moving it all over on these problems where there's the x squared. On example 3, I need you to scribble out this example. We are going to do 2 different ones on this page. So the first one is y equals the absolute value of x minus 1 plus 7 and y equals 9. My first step is I set them equal. So I'm going to have x minus 1 plus 7 equals 9. Now I want to try and get the absolute value alone. So everything on the outside needs to move, minus the 7. X minus 1 is equal to 2. Now, the absolute value in here, if I have x minus 1, if I plug in numbers, I could plug numbers in, and if I had a positive 2 in here, it would give me a positive 2 for my answer. Or, if I had a negative 1 inside the absolute value would cancel that negative, and it would be a positive 2. So I have 2 different answers that I could get. I have a positive version, and I have a negative version. Add the 1 to get x alone, and it's 3. Add the 1 to get x alone, and it's -1. I have two x values. I go to plug them in. These ones are the easy ones. We like these because it already tells us that y is equal to 9. Y is equal to 9. Those would be my final answers. If I want to, I may write them as a point, or I may leave them as x and y if you want to. On our next problem, I'm going to follow these same steps on the side. We are going to set the equations equal, x minus 1 plus 7. So I'm substituting it in for y and saying it equals 5. Then I try and get the absolute alone. X minus 1 equals -2. When I do the absolute value of a number, it will never be a negative. The only way to have that is if there's a negative outside of it, but there's not. So this is absolute equal to a negative. No, so there's no solution. And you would just be done. There wouldn't be any pieces, or there would be no intersections for those two equations. On example 4, I want you to cross it out, and I want you to write in these two equations. We are going to first set them equal. So I set these two equal to each other. I want to get the absolute value alone, so we minus the 2. I can't minus the 3, it's stuck inside. This 4 is attached on the front. If it's on the front, it's being multiplied by it. So to undo, I divide by -4. X plus 3 equals a +5. Now that I have my absolute alone, I separate it into my two answers. It could be a +5, or it could be a -5. Solve for x. Solve for x. Then I look for y. Y is really nice. It's a -18, so I just copy my y in for my 2 points. If I want to write it as a point, I can write xy, xy, or I can leave it as x equals and y equals. The last example is going to be an honors problem. So we're going to substitute in for y. So this piece right here, I have x squared plus y squared equals 9. Now because y is equal to x minus 5, I can take it and plug it in. Now I simplify. X minus 5 squared means I need to write it 2 times. I distribute. X squared minus 5x minus 5x plus 5 times 5 is 25 equals 9. Combine like terms, there are 2x squareds. -10x's plus 25 equals 9. Because there's an x squared in here, I need it in the form ax squared plus bx plus c equals 0. So that means that 9 needs to be moved over. Now I have a, b, c. I'm going to use the quadratic formula on this. So I would get negative b plus or minus the square root, b squared minus 4ac all over 2a. I plug that negative 10 in and it becomes a positive. Then I do b squared minus 4ac get negative 28 over 2 times 2 is 4. Now that means it's imaginary and there would be no solutions. Now, so that would be the answer for this one. If I had gotten a number in here, let's say, I'm going to make this up. So this is not true, I'm just making it up. Let's say I got 10 plus or minus the square root of 16 over 4. Then what I would do is I would square root it, find my two answers. 10 plus 4 is 14 over 4. 10 minus 4 is 6 over 4. Those would be my two x's. And then I would just take those and plug them in and see what my y's equal. And then I would be done. So if you get a question like this, just remember it's honors.